Welcome to this webinar about forensic odontology. My name is Simen Kopperud.
And my name is Sigrid Kvaal.
Sigrid is one of the leading forensic odontologists in Norway. And Sigrid, how did you get into forensic odontology?
I started with forensic odontology in 1988.
So what fascinated you about this topic?
I think it is the identification. When people are disappear in an accident or has gone missing for any length of time, when we do an identification, the family gets some sort of peace of mind. And I think that is one of the most rewarding things with forensic odontology. How did you get into this field?
I have been a scientist at NIOM for some years, but a couple of years ago I also got a position as a military dentist in the Norwegian Armed Forces, and they wanted me to focus on identification.
Most of the work we do is by single identification. People who are found dead in the sea, in the mountains or in the woods, or even in their own flats. I will first introduce two words which we use very commonly in identification work. That's AM, which is short of the Latin antemortem, and PM, which is short of the Latin postmortem. Antemortem means before death, and postmortem means after death. When a body is found and we have to do an identification, we have to do a comparison between what we know belongs to that person. And one of those things is the dental records. The dental records consist of the written records. Most of the records we receive today are computer records, but I also previously seen lots of handwritten records and also typewritten records. Another part which we need are the dental x-rays, and we need all the dental x-rays. Some picture will show something, other picture will show other things, and that means that all the x-ray, not only the last one, will be important when we collect it. In addition, plaster models, or today we might even receive the electronic models, also pictures who might show identifying features which are not shown on x-rays or in the dental records.
Okay, so what do you do with this antemortem information?
We change it from a treatment record, which record what's been done at the different dates, to a status record, which we presume is what we expect to find in the body. And we enter it into the computer program made by Plastdata in Denmark called DVI International.
Okay, so the body is found and the antemortem material is collected. Then what happens? What do you do with the body?
The body will be transferred to a forensic institute where a postmortem will be performed. That will include a postmortem dental examination as well. I brought with me a skull just to show you. Sometimes we get material which is virtually like a dry skull, and we can do it this way, and if you hold it there, and sometimes have to clean it, and I use a normal toothbrush with soap and water and clean them so I can see what it is. And I then take a mirror and probe like I would do in a normal practice, and I do a registration of what I can find. Now this skull doesn't have any fillings or any other peculiarities. He has got a fractured cusp there. I will note that, and he has got a missing front tooth as well, and a fractured tooth there. That might have been recorded in the dental records.
And do you also take some x-rays?
Yes, we have a portable x-ray machine, and we would then put in the sensor. And normally we try to take x-rays which are similar to the ones we anticipate to be found in the dental records, which would be a bite wing. Now if we put it in like that, I'll put the cord on the other side, and then you focus the machine against the sensor, and you will then get an electronic picture of the x-ray.
So now we have information from the dental examination and the x-rays, and you also have all the antemortem information. Now Interpol have specific guidelines for identification of victims which says that identifications can be done by comparing fingerprints, DNA, and physical indicators like scars, tattoos, and surgical implants, and by comparing dental examinations. So how to do that?
Interpol has developed forms which is standardized so we can use them. It's lots of information about body, fingerprints, DNA, but it's also from the dental one. And if you take that one, that's the yellow one is from AM, the pink ones are almost identical, and they are the pink forms. Then it's easy to see what is antemortem and what is postmortem. And on the dental ones, we have an odontogram, and that's identical, and it's very easy then to compare. We do comparison by comparing each tooth and see that there are similarities, and to do an identification there should be no dissimilarities. And this way we go through and see that it is correct. These are blank forms, but in a real case it will be filled in with details.
Here at NIOM we are very interested in all kinds of dental biomaterials. How do dental biomaterials contribute to the identification of individuals in these forms?
That would be that you compare the fillings. An amalgam filling in the dental record would have to be an amalgam filling in the PM records. A composite filling would be a composite filling in the antemortem records, and a composite filling in the postmortem records. And that with gold, acrylic, crowns, bridges, and endodontics as well. And we may be able to see on the x-rays what sort of material it, and it's recorded in the antemortem what sort of material it is. Occasionally, we have to take it out and ask NIOM to do an examination of what type of material this can be.
So if the forensic odontologist can conclude that we have a match based on the dental examination, what happened with this conclusion afterwards?
That information will go to the Identification Commission, and they will make a final conclusion based on all the information that have been gathered. In that respect, if we have got a dental match, then that will weigh very heavily.
Sometimes we may get a case where we have no idea who the person might be. And I know that you were involved in a cold case like this from the 1970s quite recently.
Yes, the Identification Commission asked me to look into the case of the Isdal woman.
That's Isdal-kvinnen in Norwegian.
She was found in 1970 with no identifications. They have later on found her suitcases, and in all her clothing, all identity marks, labels, etc. has been removed. And she had 7 different passports with different names. I've been asked to look at her teeth, and here I've got a picture of her jaws. And as you see, she has got quite different dentition from what we normally see in the Norwegian population.
Yes, I can see that she has quite a lot of gold restorations.
Yes, she's got a full gold crown here, but that was not uncommon in the 70s. She has got 2 front crowns. They are made of a combination between acrylic and gold, very often called combination crowns. But she's got 2 bridges in the lower jaw, and they are made from in a manner which we don't see in Scandinavia. They are called kombinationskroner in German, eller båndkroner in Norwegian, and I've never been able to find out what the terminology is in English, which indicate to me that it's not likely that she comes from an English-speaking country. You might notice that she has got 3 teeth missing in the front of her mouth, but these are actually extracted post-mortem. The 2 front teeth has been used to estimate the age, and this one I think has fallen out.
Here at NIOM we have laboratory premises which may be used to analyze these materials more closely.
Yeah, the material was analysed in the 70s in Denmark, and I got the papers for that. But I'm sure that NIOM today has got different and more sophisticated method to analyse the material. So that would have been interesting.
Let's have a look on that. In this room we have one of NIOM's most recent investments, a scanning electron microscope, which is operated by my colleague Dr. Amund Ruud.
This is our scanning electron microscope, or SEM as we call it. You are probably familiar with a light microscope, and the SEM takes advantage of the same basic principles as a light microscope. However, we use electrons to study the surface of our samples instead of light. The benefit of using electrons is that you can go to much higher magnification, which translates to looking at much smaller objects of the surface. Furthermore, this instrument has the benefit of identifying different elements in the sample. So to relate this to dental identification and the Isdal woman, we know that the composition or elements in all kinds of dental materials vary between the different brands, but also like in wine production, the elements will vary from each production year. So perhaps in some cases, like the Isdal woman, we could predict the person's origin by analyzing the elements in the restorations. I have brought today a premolar with an amalgam restoration. This did not belong to the Isdal woman, but how would we analyze this tooth and what could we expect to find? Now we have put the tooth with the amalgam filling inside the SEM, and we have then focused onto a specific area of the amalgam filling. First of all, magnifying the surface 2000 times, we see that the amalgam filling actually looks quite rough in our instrument. Furthermore, we can then identify the specific elements of the surface here, and we see that we have, for instance, the characteristic mercury peak, as well as other metals such as copper, tin and silver. So our laboratory premises here at NIOM may turn out to be valuable not only for testing and research on dental materials, but also in identification work. If you're interested in learning more about the Isdal woman, NRK and BBC has made a podcast about it, featuring, among others, Sigrid Kvaal.
And the podcast is called Death in Ice Valley.
Identification of single cases is the most common task for forensic dentists. But from time to time we may experience so-called mass disasters, accident, terror actions or natural disasters with a need for identification of many victims at the same time. In Norway we have experienced disasters like the fire in the ferry Scandinavian Star in 1990, the plane crash at the Opera Mountain at Svalbard in 1996, the train accident at Åsta in year 2000, and the tsunami disaster in the Indian Ocean in 2004. Although not all of these disasters happened on Norwegian soil, most of them involved loss of Norwegian lives. Now, Sigrid, you were involved in the identification process in many of these disasters. Can you tell us about how this work was organized?
The Identification Commission in each country consists of police officers with fingerprint experts. It consists of pathologists and DNA experts and also forensic odontologists. Depending on the disaster, if it's a disaster abroad or a national disaster, the organization will be slightly different. If it happens in Norway, we will find a place where the post-mortem examination would be performed. Police would go out to collect the bodies and get those in, and also a group, both of dentists and police, would be working to collect ante-mortem information. That's not only the dental information, but it would be pictures, it would be description of clothing, it would be the DNA information, etc.
But may I ask, if a disaster happens today, how fast will this group be ready to go?
We will be ready to go almost immediately. We have equipment ready, we have personnel who knows what to do, what the task is, what the responsibility is, and we can go anywhere in the world.
This happened in 2004 when a giant tsunami hit the Indian Ocean on Christmas Day. Sigrid started up in Norway, leading the work of collecting the ante-mortem information. But then, after a couple of weeks, she went to Thailand. So how was the work organized when you came to Thailand?
We had containers where the post-mortem examination and the dental examination were performed. We had freezer-wagon where the bodies were kept. So that was much more streamlined. I was asked to do comparisons. By that time we had some antemortem information, and of course we had lots of post-mortem information as well. We worked cross-culture, cross-linguistic difficulties, cross-legal obstacles, and pulled together to get the right people sent back to their families.
Traditionally, dental identification is based on restorative materials in the victim's teeth. But what about the caries-free generation?
We can look at other characteristics, and one of them would be the morphology of the teeth. I've got a book here about teeth from Simen in London, and he has got some good illustration of the different morphology of human teeth. And here you can see the incisors with a shovel-shaped, and here you can see it's an extra cusp also on the incisors. And of course quite a few has notably peg-shaped lateral incisors. And if these are noted in the dental records, that would be something we could recognize as a characteristic trait.
So I guess we have to highlight the importance that dentists register all anatomical structures that can be used for identification on a later stage.
All anatomical characteristics which are a bit unusual. And on the premolars, they have even more variations. They can have almost only one cusp, or they may have 3 cusps. So that is something that can be noted, or a photograph of this would be an ideal thing. Then we could go right in and see what they look like and compare it. Another possibility would, of course, be models.
Definitely. We also have some of the same for the molars.
Yes, the molars, you can either look at the fissure pattern, which I generally described as being either a cross or a Y-shaped. But I think it would be easier to look at the number of cusps. Molars can have 3, 4, 5, or even 6 cusps. Have you noticed that they can even have extra cusps?
Yeah, I've seen that in patients, and we have some very good images here that can indicate what it looks like for the dentist.
Yeah, the carabellic cusp can be virtually non-existent, up to absolutely an extra cusps. And the same with the protostyloid, which occurs on the molars in the upper jaw, but it is rather on the buccal side rather than on the lingual side. So before we looked at we couldn't differentiate between we could differentiate between composite fillings and metal fillings. But today, when there are few fillings, it might be much easier to look at the morphology of the teeth.
So far we have only talked about identification work, but forensic odontology have some other aspects as well.
Yes, one of them is bite marks, but this is quite a controversial subject, and I think I would leave that to experienced forensic odontologists.
How about age estimations?
I've been involved in age estimations. It's been a lot of focus on that lately, especially a couple of years back when we had a lot of asylum seekers. Some of them appear to be older than the 18 years which they said. But there are other aspects of it. You have adopted children, you have people coming in wondering if they are old enough to get a pension, let alone all the age estimation related to sport, human trafficking, children's work, etc. And this is an area where we do a lot of research at the moment, both on bones, on teeth, and on genetics.
So it's an important field as well.
That's a very important field.
So to sum up, forensic odontology must be considered a selected field within dentistry. But any dentist might be asked to submit antemortem material. Could you repeat what that is?
That's a full dental record. It's X-rays, both two-dimensional and three-dimensional pictures. It's photographs, it's model if you have one, and any other material which might be relevant.
Thank you for watching this webinar.